Hello friends, welcome to Module 8, Drones Technology, Drones Fun to Fly and Fantastic to Make Money. And this module is FAA regulations, FAA Part 107 of 14, CFR 14. So CFR, as you know, Code of Federal Regulations. So once we get through part 107, we are out of the woods. Yeah, we are going to come this far. So let's get this done. Before I don't worry about it. I've got about 15 pages over here, but I'm not going to bore you going through all these pages and reading out to you. If I do that, the whole theme, drones fun to fly and fantastic to make money, would be defeated. So let's get through this in a more upbeat manner. Okay. Before I get into this, I would like to show you a few things in terms of there are a few ways you can go into the same this is in the FAA website. There are a few ways that you can go into the same position. Okay, this is the home of FAA. Okay, what I would, let me see whether you can see this a little better. All right. Okay. What you do is when you click on that icon, that is drones unmanned aircraft systems, UAS. I have same let's see now, under that, why don't we see the that I have shown on this one also. So once you click on that, then directly you find this icon, and you can click on that. That will take you to part 107 test prep. And I have put over here also, before you fly, that you can download to a smartphone. That's the app. And that gives not only a lot of information. Once you log in from that, it'll tell you whether it falls into any restricted area, whether you can fly your drone in that area or not. Itself, it'll tell you. Now I need to alert you for another important factor over here. I'm going to show this because there are two other websites. I do at least under FAA you got the FAA safety.gov. That's where generally we can go and do the part 107 course. But if you it could be a little confusing. In fact, I had this problem myself. There's a training website. You call it let me give you the correct name on that. Now you see that better. You got the Integrated Airman Certification and Rating Application. So by mistake, if you go there, you would not be able to, even if you log in, you will not be able to do anything until you get the part 107 get through the part 107. There's a document ID that you will get. So if you go in here, you might get confused. So go through the steps that I was relating to you. I will do it again and make it a little more confusing. I'm not saying that FAA's websites are not user friendly, but this thing I want to alert you because I myself did this mistake. There's another website you call it IACRA training site. So this is for the training purpose. I do not think for the remote drone pilots the training site you require to go even, because that's sort of straightforward more than the regular pilots and other mechanics, engineers courses that they have on the website. So once you do that, let's see whether we can get in. Yeah, once you click on, let's see now. Let me get my cursor over there. Am my cursor behaving properly or no? Alright. I got it. Okay. Once you click on this icon, drones, unmanned aircraft system, US, then you can get into part 107. Then it will open up over here, introduction and course overview. Well, I'm showing. Oh, I'm not pointing the correct thing. Okay, how about that? Okay, you can go to introduction and course overview over here. So that I'm trying to get rid of some confusion. Hopefully in the process I didn't confuse you even more. Now let's you may not see my face, but I don't think that will matter. Only thing is on this one other thing I'm going to show. This is the National Airspace classification. I want you to this of course we will have under module 8 figure 4 we will have a screenshot of this, but you can of course even FAA if you go it's there in some place in FAA also in a different graphical display, but the same idea is there. You got class A up there, this from 18,000 feet to 60,000 feet, you are not supposed to be there. And you got class B airports, you are not supposed to be there, busiest airports. And class C moderate busy airports, you are not supposed to be there unless of course with permission. Class D small airports, that's also prohibited unless you get permission. But class G you are allowed to fly. If you see this whole area, you are allowed to fly. The classification is marked over here. You will see also it's class A prohibited, class B, C and D may operate with permission from local air traffic control. Then class E and G may operate while following all other regulations. So there you go. Let me, now that you got that, let's go into the lesson proper. Okay, as I promised, I have about 15 pages, but what I'm going to do is just discuss with you, at least present you the major points that you need to know. Trying to pass at least I'm sure you can pass part 107 without much of a problem. I know if you have been following the whole course, there are so many points of part 107 we have already dealt with, and even a little more than what it is calling for in some areas. So what and then on figure, at least module 8 figure 2 gives a list of all the references that you have to go and check on not only FAA website, also what you call the Pilot's Handbook of Aeronautical Knowledge. Those the list is there. You can cross check some of the information that I am giving you. in terms of getting into Part 107 studying, of course you will have, once you get in, it will guide you straight through, step by step, and giving you a tremendous idea of what's going on with the aviation and flying your drone. Believe me, it's very user friendly. It's not difficult to go, but you must devote a little time without getting disturbed to continue that, so that you get the whole thing in proper order, which is important for safety reasons. And of course, FAA is not regulating privacy laws, but as an advisory capacity, of course they put some information for you to observe, and of course regulation, safety, regulation, and privacy and respect also. Let's get back to on rules of safe operations of small UASs, that is our drones. It gives out number one as pre-flight condition. FAA has also the pre-flight condition list. We would also put it as a link on our links page. And Drones Anywhere website, we have our own pre-flight checklist. As the first item, if we talk about the weight, maximum weight that the drone can take, what FAA advice is to go with the specs of the manufacturers. This is where Drone Anywhere and drone technology, drones fun to fly and fantastic to make money, comes in a big way to fill in the gap, because sometimes the manufacturer may not have that specs on their user manual. Then through our course, we have upgraded your knowledge to a certain to a degree that you can make a fair, responsible and safe judgment on. For example, we always say try to keep the weight at least 50% of the thrust. Don't go over that for safety reasons. And we also went into detail how to calculate that in the model of assembly of drones. Gross weight, yes. So and FAA tells on part 107, gives in details what you need to be concerned about. Exhibit, if you don't do the calculation for the weight, although the maximum gross takeoff weight is normally specified for a given unmanned aircraft, the aircraft may not be able to launch with this load under all conditions. See, there you go. That's one of the things you have to consider. Unmanned aircraft may exhibit unexpected and unusual poor flight characteristics, factors that may require reduction in weight prior to the flight. Flight includes these are the things that you should be concerned about, bring your attention to. High density altitude conditions, high elevation, high air temperature, high humidity, runway launching. Of course, that is not mainly to your drones. That is if you are having a model fixed wing, that will apply for you more. And being on a surface or a gradient on the surface, presence of obstacles. So all those will reduce the amount of weight that you can lift. So excessive weight reduces the flight performance in almost every respect. In addition, operating above the maximum weight limitation can compromise the structure and integrity of the unmanned aircraft. Of course, that you know. So as I said, the information you can find more information on Pilot's Handbook of Aeronautical Knowledge. So once again, lower maximum altitude, it will result in reduced rate of climb, lower maximum altitude, shorter endurance, reduced maneuverability. So weight is one thing that you have to be very, very concerned. Then it goes on battery powered. The weight change once it is airborne is not that much, because if it is fuel powered, it can reduce as the weight would vary or reduce once the fuel gets burnt. But then even battery powered, you have the same scenario if you are doing agriculture work. If you are spraying spraying liquid, that means as the liquid amount, as the tank empties, your weight of the drone is reduced, and then affects the control. At least the pilot in command should adjust the controlling accordingly, and change of so then that is one thing. And also center of gravity. When you load anything, you have to think, as we described in the earlier modules, you have to be concerned about the center of gravity. When the drone is initially built, of course, if it is not do-it-yourself drone, the manufacturer takes care of the center of gravity being in the middle. But when you load cameras or some other thing, you have to, it's your concern as a remote pilot in command to make sure our center of gravity is not affected. And also this may be mainly for the fixed wing, but even for the drone, when you tilt, when you are on a roll, the center of gravity changes, and then it affects the thrust and the weight factor, because you are at an angle. And in fact, on part 107, it's in a lengthy way it describes how it does, but we don't want to spend too much time on that. We are still on pre-flight conditions, and ensure that every flight can be accomplished. Yes, pilot in command is responsible for ensuring that every flight can be accomplished safely, does not pose an undue hazard, and does not increase the likelihood of loss of positive control. So you are remote controlling, but you have to make sure that your capability to do that is not hindered by any means, due to the diversity and rapid evolving nature. So there are not no hard and fast rules put through, but it's a judgment thing for the remote pilot in command. Once again, Pilot's Handbook on Aeronautical Knowledge gives you more information on that. Determination and safety operations from conditions. Determining performance operating data. If the manufacturer does not give that, what you have to do is, with the knowledge, acquire knowledge as much as possible to do sensible determination on all these. So it says on FAA on part 107, it says the remote pilot in charge can better understand the unmanned aircraft's capabilities and limitations by establishing the process of tracking malfunctions, defects, and flight characteristics in various environments and conditions. Use this operational data to establish a baseline for determining performance, reliability, and risk assessment for your particular system. So that's very well put over there. I'm sure you can understand that. Rule for safe operations. Still on pre-flight considerations, effect of weather is, as I said, is dealt in quite a detail. But we did the same thing with our weather module, that is module 6, I believe, on the course. Even though small UAS operations are often conducted at a very low altitude, weather factors can greatly influence performance and safety of the flight, especially factors that affect small UAS performance and risk management include atmospheric pressure and stability, wind and currents, uneven surface heating, visibility, and cloud clearance. As with any other flight, the remote pilot in command should check and consider the weather conditions prior to and during every small UAS flight, says Part 107 FAA. This section of the lesson describes the effects of weather on aircraft performance, especially the wind. Obstructions on the ground affects the flow of the wind. So, especially if there are tall buildings with steel structures, and as you know, I think on the remote control module 7, module 7, module 5, we went through what drones are operating is operating are two frequencies, that is 2.4 gigahertz and 5.8 gigahertz. One falls into VHF frequency, other falls into FHS frequency on the frequency spectrum, but both are not good for long range, are not good to penetrate buildings, mainly if they are steel buildings. So what it is described over here in part 107 is don't let your remote lose the signal to the aircraft because of the building, and wind effect of if there are tall buildings, there could be wind tunnels. So, and that will make the intensity of the turbulence associated with the ground obstructions depends on the size of the obstacle and the primary velocity of the wind. Even when operating in an open field, wind blows against surrounding trees can create significant low-level turbulence. Obstructions on the ground affects the flow of wind. Many may create rapidly changing wind gusts and can be an unseen danger. So we are dealing with wind in a lengthy manner here. The intensity of the turbulence associated with the ground obstructions depends on the size of the obstacle, as we said, and primary velocity. And more information you can find on Pilot's Handbook of Aeronautical Knowledge. So we did dealing with nearby building. Current also we will different surfaces radiate heat in varying amounts. The resulting uneven heating of the air creates small areas of local circulation called convection currents. Convection currents can cause bumpy, turbulent air that can dramatically affect the remote pilot in command's ability to control unmanned aircraft at low altitudes. For example, plowed grounds, rocks, sand, and barren land gives off large amount of heat and likely to result in updrifts. Water, trees, and other areas of vegetation land tend to absorb and retain heat and are likely to result in downward drifts. Okay, that's about the weather. And visibility and clouds. Yes, on part 107, they are dealing in length with that also. As in manned aircraft operations, good visibility and safe distance from clouds enhance remote pilots in command's ability to see and avoid other aircraft. Similarly, good visibility and cloud clearance may be the only means for other aircraft to see and avoid the unmanned aircraft. The regulatory requirement for visibility and cloud clearance are described and it should be noted here that adherence to regulatory requirements in conjunction with the good airmanship and effective scanning techniques can preclude in-flight collisions. And collisions avoidance is an essential aspect to the safe integration of the small VAS into the NAS, that is National Airspace System. Of course, say no more with that. It's very important. We cannot afford to get into collisions. I would like to inject a little idea with this, because this is a marvelous opportunity. But if there are collisions, then there are going to be more regulations, and people are going to lose the chance of using as a hobby or to make money or more productive work, development, and so many other things to come by can get obstructed if more and more collisions occur. So let's do the best to avoid such situations. If you take in a summary, we can say recommended maintenance procedures for small UAS that we are told. Even if the manufacturer doesn't specify, we are bringing in knowledge so that you can make a sensible determination. Inspection requirements to verify that the small UAS is in a condition for safe operation. Considerations for safe loading and unarmed aircraft, we dealt with that. Procedures for evaluating performance. The effects of weather, of course we dealt with length. And then we come into on part 107, operating rules. Part 107 prohibits operating of small UAS at night, and define in CFR 14, part 107, what is the twilight zone? Twilight zone is half hour after sunset and half hour before sunrise, and it differs in contingent US and whether it is Alaska or Hawaii. But if you are flying in twilight zone, you need to have the lights of the aircraft or UAS on. But it allows you, FAA regulation allows you to, I don't see any permission given to switch off the light, but you can dim the lights. I don't know how, maybe the newer drones you can do that, and for a short period, but you have to have the lights on. In the yes, in Alaska it's different. Resources page access. Resources page. We are going to link also the Naval Observatory website, where you can download these tables and customize them for your location. That is more on the twilight zone. 14 CFR and visual line of sight. We have to. It gives on 107 describes all the different details, but it has to be native eye or glasses, or if you're in Britain, what is it? Spectacles and contact lenses. No goggles or no FPV. If you are using FPV, there should be a observer helping you out. Minimum visibility. And then minimum visibility as observed from a location of the control station must be no less than 3 statute miles. So whether it's twilight or regular daylight, that has to be 3 miles. Minimum distance from, once again, very important, minimum distance from clouds must be no less than 500 feet below the cloud and 2,000 feet horizontally from the cloud. Important. All right. And binoculars. Binoculars, you can use it like if you do a maneuver, you want to make sure the aircraft obeys your maneuver. For instantaneously, you can do the binoculars, but you cannot be flying the drone using the binoculars. So I think that is straightforward too. All right, remote control this person. One more point, as amended. So a remote control PIC person in command or person manipulating the controls may have a brief moment, but get back to line of sight as quickly as possible. Safety operation segment to scan for traffic. So that is could be for scanning for traffic. Brief looking down at the control station, or scanning for traffic. To scan for traffic, the crew should simultaneously focus on different segments of the sky. Operational necessary, such as intentional maneuvering of the aircraft for brief periods behind an obstruction. There's no specific time, once again, but use your judgment. That's what FAA says on part 107. The remote PIC controls must attend to regain visual line of sight as soon as possible. Immediately, if he or she unintentionally loses sight of the aircraft, as soon as practicable, if she or she sight of the aircraft for operational necessity. This is another two items I want you to really jot down and mark. Operating limitations for small unmanned aircraft: cannot be flown faster than ground speed of 87 knots, 100 miles per hour. Cannot be flown higher than 400 feet above ground. That we have dealt with number of times. Okay, we are still on safe operation. Operating rules, and they did. Of course, we dealt with on the be a fantastic drone pilot. NOTAMs, notice to airmen. That's imperative that you have to look into that before going sending out your drone. Presidential TFRs and NOTAMs, emergency responses. Presidential TFRs differ in FAA. If you are in the United States, you may have to apply the similar statutory on other countries.